Hi, I'm Meta Spencer. Today we're going to Alaska, and I'm just so thrilled because I watched a hell of a lot of Northern Exposure. That's why, and I probably have 10 times my quota of Northern Exposure in my past, and so I have always wanted to go to Alaska, but I've never made it. And this time we're really going to have an adventure. We're going to go out on the ice. At least vicariously, and in the account of a professor at the University of Alaska at Fairbanks. I'm going to talk with Katie Walter Anthony, who's a professor of aquatic ecology, biochemistry, and permafrost science at the University of Alaska in Fairbanks. So, hi. How are you today, Katie?
Hi, Meta. It's nice to meet you. I am doing very well. Thank you.
Good. I'm so pleased to meet you because, as I was about to tell you, to your great surprise, and in a way to mine, you have been on the cover of my magazine. And we didn't put a name on it because we didn't know who you were until after it was published. Then I found out. So I'll show you the magazine. Here you are. See this Peace Magazine?
Okay.
And
yes.
The article, my article in it is called How to Subtract. But it's really a picture of you out on I presume a lake, and you've set fire to gas coming out of a hole in the lake. Is that right?
That's right. Yep,
Okay.
that's a lake in Alaska.
Absolutely. And I've seen a video of you out there punching a hole in the ice and then jumping back because the flames go about 8 feet tall. Right? Yeah. Okay. So this is your bag explaining to the world what kind of risk we are in because of the methane under the ice. Is that right?
That's right. It's I study what happens to carbon that is locked away in permafrost. So we're talking about the remains of plants and animals that died thousands of years ago, and their remains have been locked away in a frozen soil called permafrost. And as that permafrost is warming and thawing, microbes eat the dead plant and animal remains, and they produce greenhouse gases, carbon dioxide and methane, which then enter the atmosphere.
Okay, how long have people been worrying about that? By the way, I noticed that you did your, I guess your PhD in Berkeley, right?
No, I did it at the University of Alaska Fairbanks, where I'm now a professor. My advisor worked for a time. His name was Terry Chapin, and he was for a time at UC Berkeley.
Oh, I see. Well, Google has you down as somehow Berkeleyan, and I thought, well, we ought to talk a little bit about that because I'm from Berkeley.
Oh, you're from Berkeley. Okay. Well, I did my master's at UC Davis.
Oh, yeah. Uh-huh.
Would sometimes go over to Berkeley, but
yeah.
That's about as close as my education was to Berkeley. It's a nice area.
Uh-huh. Yeah. Oh, yeah. I lived in Berkeley 20 some years. And,
oh, wow.
Yeah. Okay. But that was a long time ago. I came to Canada in 1971. And so I don't have that much contact with Berkeley anymore, but it still feels like my home. Anyway, so we will talk more about Alaska and ice than about Berkeley.
Okay.
Now, I would also tell you that this is not totally unfamiliar territory, or the topic is not to me, because I've had, I have a show several times a week. And I've had Peter Wadhams and Paul Beckwith on together, 8 or 10 times by now. So they are good friends of mine by now.
Okay, so you know some things about methane.
You must, I expect, to have crossed paths with Peter Wadhams, at least in your quest to look at the effects of methane under the sea ice.
Yes. Yeah, that's right. Then the whole cryosphere.
Okay, so let's talk about this. When I talk to them, Well, Paul Beckwith won't let me use the word doomsday because he refuses to believe that there's no solution. But it's as scary a thing as I can imagine in terms of the potential risk of sudden global warming because of a catastrophic explosion. Let's address that right off the bat. How much do you worry about this?
Well, I like to put things, I think we worry about the unknown. And one fun part about being a scientist is that we get to try to study the unknown. So it's kind of exciting. I don't usually get worried about what I study. I try to put it into context. So on one hand, we have been seeing in some regions, for example, where I live in Fairbanks, that since the 1980s, there has been warming, and that has led to a really huge increase in permafrost thaw and the formation of lakes that are releasing this methane gas. We've had a 40% increase in lake area since the 1980s. So the lakes that I'm familiar with, the roads I drive on, the trails I cross country ski and mountain bike, I am seeing what used to be little ponds just growing bigger very fast. And that's surprising because I've been studying this since the year 2000. But in the last 5 to 6 years, we've seen the largest, most rapid increases. So it seems like permafrost thaw is accelerating. And what we know is that where you get this new thawing of permafrost, so new lakes forming, that's where we get the highest methane gas release. So if that's all I had was the context of what I've seen for 22 years with an acceleration in the last 6 years, I could be alarmed, but instead it piques my interest. And I like to look back in time and say, have we ever seen anything like this before? And when we look back at the paleoenvironmental records, we can actually determine the birth dates of lakes. I've traveled many rivers in Siberia and looked at cliffs where exposures of sediment, where the river has cut through the landscape. It's kind of like the river is a knife cutting into a great big birthday cake. And the landscape is the cake. And when the river cuts through it, now you can see both halves of the cake, and you can see the history of the earth and the permafrost in a cross section. And I can see where there used to be lakes, ancient lakes. They're no longer lakes. The water drained away and the sediments refroze, but there's evidence that there was a lake. And when I go up to those lakes, climb up on these permafrost cliffs, I can take a little sample of the sediment, the ancient sediment, and age date it with radiocarbon dating and find out when that lake was born. So I have a catalog, my students and I have a catalog of all the birthdays that we've ever been able to accumulate of when these lakes formed. And what we see is that, yes, lakes are forming today, but actually way back in time, thousands of years ago, when the earth came out of the ice age and entered into what we have right now is called an interglacial period, a warmer period, these methane emitting permafrost thaw lakes were 10 times more abundant than today. So it seems like we're standing on if the models are right, that warming is going to cause more permafrost thaw, which means the formation of more of these permafrost thaw or thermokarst lakes, then we should see a rapid increase in methane release from these lakes. But it's not the first time it's happened. It's also happened in the Earth's history. Now, what one alarming is the rate.
Expect it to have happened, millions of years ago or hundreds of thousands of years ago. But you're talking about maybe a few thousand years ago at a time when we had all the flora and fauna that now exist, and it didn't kill us then. So maybe don't worry, it might not kill us. Is that
well, there's different ways to approach this. One question is if the models are right that we will have a lot of loss of permafrost this century, in my lifetime, in my children's lifetime, how much methane can come out? And there's two ways to look at that based on what we know. Of course, we don't know everything. One is, well, how much dead plant and animal remains are still in the soil? And so what we think we know is that there's about 1,500 billion tons, which is 2 times more than what's in the atmosphere. And that's just organic carbon, the remains of dead organisms that's locked away. It's potential. It's like frozen chicken in your freezer, frozen spinach. When you open the freezer door, now it's food available to microbes. And some fraction of that will be decomposed, eaten by the microbes, and released by their metabolism into the atmosphere as carbon dioxide and methane. So there we already have a limit on how much can come out. And when we look at those numbers, it's actually, it's a large amount compared to what's being emitted today, but it's small compared to the projections of human fossil fuel emissions. It adds up to only about 10% of the business as usual scenario that we're on. So it is now I think you could say what's alarming is that you don't need to continue on business as usual to open that permafrost freezer door. Even if we mitigate, we cut back on fossil fuel emissions and we reach a lower level of fossil fuel carbon release, it's still enough to cause the permafrost to thaw and these lakes to form. And once you have a puddle of water standing out there on the landscape, that water has heat in it and it has its own self-perpetuating feedback cycle. So it causes the permafrost to thaw. So even if we as a society succeed in slowing our fossil fuel emissions, unless we dramatically cut back, even great efforts is still going to cause that permafrost freezer door to open and this carbon to be released. And when that happens, it's kind of a headwind against our efforts. Whether we are on business as usual and we release a lot of fossil fuels or we cut way back to the RCP 4.5 scenario, both of those efforts will release the same amount of permafrost carbon because it's a matter of opening the door or not. And when that door is open, the carbon comes out. So we have an idea of how much could come out that way, but there is another wild card. In permafrost and beneath permafrost is methane itself. I'm not talking about dead plant and animal remains now. I'm talking about methane molecules. And that methane has been trapped for longer periods of time. It can be associated with oil, it's natural gas, or coal, sometimes just microbial methane from ancient sedimentary basins. And so in that case, we have natural rock layers that prevent that methane from coming out, but permafrost itself it also slows, it's like a cap. It's not a perfect seal, but it slows the release of it. So if we start to either pull back permafrost or get holes in the permafrost, then this fossil methane, it's natural gas can escape. And we're already seeing that taking place. That is much more of a wild card. We don't have a good idea of exactly how much methane is trapped down there or the time, how much of it's already coming out, the time scales at which it will be released. There's certainly some modeling estimates that say we're not going to have any kind of methane bomb explosions, nothing catastrophic, but still it is an extra source that I would say we don't have a good scientific handle on.
Mm-hmm. Okay, that fits what Peter Wadhams has been telling me, because he's not talking so much about the permafrost on land, which is, I think, where your specialty, but the permafrost under the Arctic Ocean. And he talks about a layer of permafrost at the bottom. I don't know how it got there. I guess it slid off or something into the shallow shelf off the.
Well, what happened is that when we came out of the ice age, when the Earth was in the last ice age, sea level was a lot lower. And it was because the water on Earth was locked up in ice sheets and glaciers. And so as the Earth emerged from the ice age, all that ice cap melted and the water went into the ocean and the sea level rose and it flooded the continental shelves. So during the ice age, those continental shelves were permafrost with mammoths roaming over them and building up all this carbon in the soil. Then as the ice age ended and all that ice, much of the ice melted, it went into the ocean. the sea level rose and it flooded the continental shelves and it put permafrost underwater,
Okay.
under the ocean.
Yeah. All right. Well, apparently there are holes in that permafrost. So the seal that's keeping the methane reservoirs down has punctured here and there.
Yes,
And there are plumes of methane coming up, right? I saw
that's correct.
a video, and I wish I'd written the URL down because I've looked for it and can't find it. It may be by a colleague of yours, a Russian woman, Natalia, something starts with an S.
Shakova, yeah.
Sharkova?
Natalia Shakova, yeah.
And there was, I think she goes off to, is it the Laptev Sea every summer and she, cruises around on the ocean. But I saw, at least whether it was hers or somebody else's ship, going through what looked to me like if I were in a plane going through clouds, white clouds all around me, except up ahead, you could see them popping up. You could see a poof, and here would come a plume of this white gas, and it was everywhere. and if it's that amount everywhere, many times a year, that itself has to be not insignificant. Do you know what I'm referring to? The particular video of that expedition?
Well, I'm familiar with the research. I haven't seen that video, but what she was showing in the Laptev Sea, the East Siberian Sea, we also see in lakes on land.
Uh-huh. Well, that's why I had the photo of you poking a hole in the ice with the flame coming up. Uh-huh.
Yes. So if a person were on a boat on the sea, and the Laptev Sea is not the only place where this occurs, or if you were on lakes on land, it is possible to find locations where there is tremendous seepage of methane gas. But a bubble is a bubble. And until you capture that bubble and find out what's in it, and you look at its isotopes to understand where did it come from, then it's a lot of speculation. So there's several challenges. We need to know, is the whole ocean bubbling? No, it's not. There are certain discrete locations.
Mm-hmm.
All the lakes bubbling? Yes, all the lakes are bubbling, but the magnitude, those great big strong clouds of massive bubbles, they only occur in a few lakes. And they're awesome when you see them. They're jaw-dropping because they're so amazing. And you just wonder, how deep in the earth is this gas coming from? And is there a decomposing mammoth down there? Or is this leaky coal beds? Has it been trapped by permafrost or not? If so, is it a new thing? Are we going to see more of these? Or have they been there for a long time? So those are questions we still need to answer in submarine permafrost environments and terrestrial permafrost environments.
Mm-hmm. Okay, now these lakes.
Stage of mapping how many there are today. And then we have the challenge to go back in time and say, well, are they new or have they always been there?
Mm-hmm. Okay, you're referring to these new lakes, which is interesting and new to me. But I have heard, in fact, I've seen photos of circular pits, cavities in Siberia, where there have been explosions of methane that make a big cavity about, looks like a city block square, or they're not square, they're round. But I think I've heard that there are about 20 of them so far that they found in Siberia. Are there any in Alaska like that? And is that where the new lakes are coming from? That they have the explosions that have filled in with water? Or what's the source of these lakes? And please explain these whatever they're called, these holes in the ground.
Yeah, these sinkholes, these Siberian sinkholes. Well, if a person were to look at Google Earth or fly in an airplane over the Arctic and look out the window, you would see millions of lakes. And those lakes formed where the cryosphere is degraded. So many of the lakes in Canada on the Canadian Shield were in places where the ice sheet used to be, and the ice sheet pulled back, and they were formed by glacial processes. Glaciers carved out places in bedrock, or ice that was stranded from glaciers melted.
Hold on, wait a minute. I'm hearing two different explanations. Holes that were dug by melting glaciers, that's one thing, but
I'm going to get to it because you are pointing out what the news likes to bring up and make a big deal about, which is a very rare phenomenon. So I want to put it in context so that we're not being alarmist.
Okay.
So you're talking about these very dramatic, and I've never seen them in person, but I've seen photos too. They're awesome. They're these round holes, very deep, icy walls. New reindeer herders are discovering them. Now that people have drones and satellite images, people are starting to find them. They're newly recognized in Siberia. Again, are they a new phenomenon? That's the science question that has not been well answered. But I would like to put those into context. The Arctic landscape has millions of lakes, most of them formed naturally by glaciers receding and ice sheets receding. In other regions where there were not glaciers and ice sheets, and we had ice-rich permafrost. So now I'm talking about the territories where the mammoths used to live. There's a lot of ice in the ground left over. And as that ice melts, I'm talking about ice wedges the size of garages, car garages. And they form in regular patterns. So it's pattern ground, they're in polygons. There's ice wedge networks all across the ground. And when that ice melts, the ground sinks, subsides, and it fills with water. And the soil that used to be frozen decomposes, makes methane. Modern plants and vegetation fall into the lake and decompose and make methane. That's a very common process. It's been going on for a long time. And these lakes are all emitting methane. We call them thermokarst lakes. Now we're getting into so that's all microbial methane. And that's microbes are chewing on carbon that's been locked away in the permafrost for a long time. And that's common. Now you're asking about the Siberian sinkholes. Do we have any of those in Alaska? This is a tiny, tiny sliver of what's on the landscape. It's a tip of a pin, except it's extreme and it's visually exciting and it's scientifically mysterious. So we, for those reasons, care about them. We want to understand what's happening. Will we see more of them? Is this evidence that there will be a methane bomb? And those are all valid questions to ask. Again, I don't think we know enough. Yes, people have just started to recognize them in Siberia, but maybe it's not a new thing, because once those sinkholes form, they tend to fill in with water and they can get covered up by lakes. So perhaps it's a process that's been going on. We have no evidence that it's accelerating. I would say we've only recently recognized them, and we need to pay attention to them. Perhaps it is a sign that things are changing faster and we're going to see new types of methane coming out. We need to know. Yes, we have seen something like this in Alaska. There's a lake in Northwest Alaska called Easy Lake, where I've worked, and I found out about this lake from a pilot. My way of finding the big methane seeps is I like to talk to pilots, or I get in airplanes myself, and I fly around the Arctic when everything is frozen, and I look for little holes or big holes in ice that should be frozen and it's not frozen. And they're often round holes. And the reason they're not frozen, my guess, is that there's gas bubbling up, and the gas bubbles prevent the ice from freezing. So that's been my way for a long time of finding these methane megaseeps. And pilots fly for their jobs, so they see a lot, they know a lot. So a pilot tipped me off to a particular lake in Northwest Alaska, and I went there on the ground with my student, and we rode around the lake in our pack raft, and we had a little depth sounder so we could determine, as a fish finder, how deep the lake was. And everywhere it was about 1 meter deep, or 3 feet, except where these huge plumes of methane were coming out. And it was actually the most methane I've ever seen. The bubbles were bigger than my head. Sound I'd never heard before. It almost sounded like gas coming up through pipe. We were in the middle of nowhere in the Arctic, but we went over it.
You could hear it too.
You could hear it. Usually you don't hear it, but in this case, we could hear the gas gurgling up through the sediments and rocks. It was a strange sound. The bubbles were so big. So you wonder, can I breathe there? Let's proceed.
Okay.
So my student and I were going along across this lake, measuring how deep it was. And when we got to the location where the bubbles were coming out, everywhere it was about 1 meter deep. But when we got to the location where the bubbles were coming out, the bottom of the lake practically dropped off. It went from 1 meter down to suddenly 15, just this great big cavity where the gas was streaming out. So that dramatic, we call those sinkholes, pock marks. And this was a huge pock mark. It's bigger than what had been observed in the Mackenzie Delta in Canada. It's not as big as these terrestrial ones in Siberia, but I would say the morphology is similar. It's got very steep slopes, and we see in the aftermath of, I don't know if there had been an explosion, nobody was there, but it looks like it could be related. And so what you have is a lake formed in permafrost, and what a chimney has formed that allows gas from deeper to come up through this thaw chimney and come out in very large quantities, erupting at the surface as plumes of methane bubbles.
If you had been smoking, would there have been a danger?
Well, we were concerned about that with being out there with some of our electrical equipment. Probably not, because I was concerned, but we weren't smoking. And later, once we'd worked enough in the environment, I actually did light a match. We always do a field test. So that picture of lighting methane on your magazine is not just fun and games, because we go to so many different lakes and we see these gas bubbles. Methane is flammable. Methane is a flammable natural gas. But if you don't have methane in the bubbles, then that gas that's trapped will actually put your match out instead of igniting it into a bigger flame.
If it's not methane, what else could it be?
Well, what we have seen in some locations is high rates of bubbling of overconcentrated nitrogen that occurs 90% nitrogen instead of 79. The air is 79% nitrogen. So sometimes you get nitrogen bubbles. It's rare, but it occurs. And so we always, when we have the chance, try to light the bubbles on fire. It's a quick field test. Is it methane or is it nitrogen? And if it's methane, then we take samples to understand more, where actually is this? Is it young? Is it old? Is it coal and natural gas, or is it microbial?
Can you capture some of it? Can you take a paper bag or plastic and capture a bag full of the emissions?
Yes, we can. In fact, in the book that I wrote, I described how, as a graduate student, that was my problem. How am I going to capture this gas and quantify it? And so I was in Siberia in a remote field station, and just had to use the materials that I could find around me there. And a lot of it was roadside garbage, metal left over from the Soviet military stations where people had abandoned them and had just left lots of scrap metal. And then I also used the Siberian greenhouse plastic, and I built skirts. They were about 1 meter, 50 centimeters wide, sometimes a meter wide. And they had a hoop metal ring around the bottom, and they were little funnel skirts. And so I could float those in the lake and the bubbles would come into them. And then I took just a soda pop bottle or a water bottle or a beer bottle, a plastic bottle, 2-liter bottle, upside down, and the bubbles would come into the skirt and then they would funnel into my bottle. And I had a spout at the top where I could measure the volume of gas that collected, how fast was the methane bubbles accumulating, and then I could take samples of it. Methane is clear, it's odorless, and what's really interesting, so we always talk about billions of tons of carbon. and my job was to find out, with these bubble traps, how much methane was coming out of the lakes. So I would collect samples, and I had these clear glass bottles with supposedly methane inside. So I would bring those bottles back to the lab. And to me, one of the most fun moments I ever had as a scientist was taking the clear, odorless, seemingly weightless methane gas in my bottle, extracting it, putting it through a cryogenic line in the laboratory, methane is a carbon with 4 hydrogens. And so through this process in the laboratory, we removed all the hydrogens until at last, all I had was pure carbon. And I had a little piece of graphite that I could see and hold and feel in my hand. So it was the carbon in my hand, this graphite, was the exact carbon atoms that were in the methane in my bottle.
My goodness. How
we radiocarbon dated it, and we found out that the age of the carbon in the methane had the same age as the mammoths. So this methane that was bubbling out of the lakes was probably formed from the grasses that the mammoths used to eat.
Isn't that amazing?
It was amazing. It was one of those moments where all this theory and math and chemistry that you do on paper actually turned into a real physical thing that you could hold in your hand.
My goodness, what is it, like 30,000 years? When were the mammoths there? They were there quite a while, weren't they?
They were there quite a while. Towards the end of the last ice age is when a lot of them date to. So, and then they extended into what's the interglacial, the Holocene. And there's a lot of discussion about what caused the mammoths to go extinct, whether or not they starved to death or ran out of fresh water or were hunted, or did climate change. So
I've heard people arguing that they were hunted to extinction, as were all the other megafauna of the area, because there are a lot of big critters besides the mammoths. But I find that really astounding, because there can't have been that large a population of human beings, and going around slaughtering hundreds of thousands of mammoths just seems to me, it's really kind of hard to imagine they did that. What do you think?
I don't know enough to have a very strong opinion, but I tend to agree with you that it was environmental change that led them to go extinct.
Another piece of research or project that I am very interested in, and I wish I'd get around to or have the nerve to ask for an interview with the Zimovs in Siberia, because I'm just amazed at their project.
Pleistocene Park. Yes, you should interview them. They're fascinating. There's a new documentary film out about Pleistocene Park, and I highly recommend it.
Another one. Okay, because I've seen several, and I've interviewed Luke Tergis, somebody, yes, and another couple of people who've been there. So yes, I must try to get to Nikita Zimov, because
so in my book that's coming out in May called Chasing Lakes, it takes place at the Zimov science station in Siberia. That's the setting of it. So you get to know those characters pretty well in the book. And you said you didn't think people could hunt out the mammoths, but if you look at how people hunted out the bison in North America, and I live in Alaska, and you can see wildlife there almost every day. You can see a moose or a bear or caribou. But in Siberia, where I've spent many years, very rarely did I ever see a wild animal. There's not a ton of people in Siberia. It's an extremely sparse population, but you don't see animals because people are good at killing animals when they want to and when they need to.
I remember being in Stockholm for something and having dinner in a restaurant, and I ordered what they called elk, but it turns out they were really moose. And then I saw, that's what they call them. They call them elks, when they're really moose. But then I saw a video that explained that, they eat a lot of moose meat in Scandinavia, because there are hundreds of thousands of moose, and they actually go out and use them as a major source of meat. So it must be that different parts of the world have different concentrations of large animals in the wild. Do you know about that? How much variation there is? Because I didn't realize that there was a difference between, say, Siberia and Alaska. In fact, I would have assumed there'd be more wildlife in Siberia than in Alaska. I don't know why I would guess that, but I'm wrong, I guess.
Well, I think definitely different regions can support different densities of animals. based on food resources, basically. But then when there's a hunting pressure, in Alaska, people respect the laws that protect animals more than they do than in Siberia. So the Zimovs are trying to bring back these animal populations. But I think that if they succeed, one challenge will be humans, because humans that don't have anything to eat or maybe haven't grown up in a culture of respecting the laws, that habit of killing the animals.
Well, do you believe their theory? You know, we should explain what we're talking about, because why don't you take a crack at it?
Sure. Well, what Sergei Zimov and his son have combed the beaches, and they've walked along the rivers and the Arctic Ocean coasts, where there's these tall cliffs of permafrost that are thawing and retreating. And what gets left behind on the beach are the remains, the bones of Pleistocene mammoths and woolly rhinos and lions and horses, these megafauna from the Ice Age. And so they have collected the bones, and they've calculated the density of animals that the Ice Age ecosystem supported. And during the Ice Age, while a lot of Europe and North America were covered by ice sheets and glaciers, big parts of Siberia and some pockets of Alaska did not have glaciers. It was a productive grassland ecosystem that supported these large megafauna. So the Zimov said, what if we could bring back those animal populations, have high density of animals? And their idea is that today the Arctic is covered in shrubs, little willows and birches and alders. And their idea is that if we had lots of grazers, herbivores, like we used to during the Ice Age, like Earth used to during the Ice Age, then they would promote a grassland ecosystem again, and that they would be able to sequester carbon in the soil and help preserve the permafrost and slow its rate of thaw. And also it would provide the natural resources and a rich ecosystem with the fauna back in Siberia the way it once was.
Well, and they claim that they have established that they have an area that is the size of a provincial park or something, I guess we'd say in Canada. And they've fenced it off, and they've imported large animals, as many as they can bring in. And they claim that these herds have actually decreased the overall climate, not the climate, but the soil temperature degree or so, just by having herds moving around, kicking the snow aside to get at the frozen grass underneath, and also knocking down trees while they're still saplings and can't grow, and they don't like trees in the Arctic. So they claim that they have these large herds of animals would keep the Arctic back, reduce the overall temperature of the Arctic, if we could get them to grow there and bring in, I don't know how they expect to replenish the Arctic with hundreds of thousands, if not millions. It probably would take several million big animals. And they, as I understand it, they go out and feed those animals in the winter, which means that maybe those animals really couldn't make it on their own if they were just put out in nature and had to survive without human help.
Well, I think that they've brought animals in from other regions. I think their bison came from Denmark. So initially they feed the animals, but their idea is that in the winter, the animals are going to browse and graze, look for grass. And so the animals will disturb the snow. Snow is insulating. And if there's heat trapped in the ground, snow is going to keep the ground warm and prevent the really cold winter air from penetrating and keeping permafrost cold. So if you can remove the snow, it's like taking off your down coat. You'll get cold. If you can remove the snow, the winter cold air temperature can freeze the ground more solidly or keep it cold. So the animals, by looking for grass and kicking up snow, are taking off the down coat and helping their idea.
But there's also the claim that
I like their idea better than putting aerosols in space and doing some other things. Humans always are thinking we're recognizing problems and then taking it in our own hands to solve them. And we've just seen we create more problems than we solve many times. So it's probably the answers to climate change are going to be multifaceted. And there's a lot that I like about the Zimov's natural approach. There's many benefits, even if they don't fully succeed in keeping the Arctic cold, back populations and having animal populations and having a healthy ecosystem. There's many good things about that. So I support doing more research on it. And
okay, what do you think about the trees? That's another issue for me. Was, they don't want trees. They go around knocking trees down with their bulldozer or whatever they have, and because they say that the trees actually have a warming effect. Well, I've talked to different foresters trying to find out, well, do the trees have detrimental effects or not? And it seems nobody's quite sure, but if they do, it may depend on the type of tree. There's a guy who's written a book called Tree Line that I just interviewed, and he went all around the Arctic, and he said there are different types of trees that grow in different areas. Each country has its own most popular type of tree. So he wasn't too scary about, but he doesn't like the idea of trees in general in the Arctic. So by knocking over trees, do they actually help keep the soil colder?
Well, people knocking over trees with bulldozers is not going to,
no.
That's not a practical way to keep trees out of the Arctic. Their idea is that animals will replace, animals naturally promote a grassland ecosystem that would take the place of trees and shrubs. I'm not an expert. I study lakes and you're asking about trees, but my observations, to get to the lakes, I go past trees very often. And I think trees, my observation is that they do have a warming effect. Of course, I haven't measured it, but I see that the snow melts out around the trees much before it melts out around the open areas.
Mm-hmm.
Even now in Alaska, there's a lot of snow, it's melting. There's no snow under the spruce trees, but if you move away from the snow trees, you still have several feet of snow. So the dark leaves absorb that incoming solar radiation, and they create their own little microclimate. Trees and shrubs collect snow. When snow is blowing across the landscape, it accumulates on these, you get thick snow deposits around shrubs. All that snow is an even bigger down coat. So it is going to insulate and warm the ground even more. So we actually see some very fast permafrost thaw in areas that are very shrubby. Mm-hmm. So I'm not an expert, but it does make sense to me that having a grassland instead of trees and shrubs is one way to promote permafrost.
So I'm glad you're saying this, because I'm very favorable to these people. Of course, I have no basis for having an opinion, but I have more than my shares of opinion anyway. But on any topic, I tend to form conclusions, and I like what the Zimovs are doing. And I'm glad that you basically say it certainly can't, it's not going to hurt, and maybe it'll help. A question, I think, is it practical? Could you actually import and create immense herds of large animals? I don't know. I'd be skeptical. But also...
Well, people are doing these experiments in other places, not for the sake of permafrost, but there are other rewilding projects where they're trying to bring back the bison herds that once lived in North America, for example. So we could learn from that. And then what happens if you take this whole thing further north into the extreme Arctic?
I saw a map of where the carbon deposits in the permafrost are located in the world, maybe it's not all in permafrost, it could be in ordinary unfrozen soil too, but apparently Siberia has stupendous quantities of carbon in the soil compared to any place else. It's almost like Siberia has as much carbon in the soil as all the rest of the world put together. I'm making that up, but it was an amazing chart. And do you think that's because of the previous presence of these huge herds of animals?
Yes, it is. Well, the herds of animals occurred where these very carbon-rich permafrost deposits are at. So I don't think that the animals, I think that what it was a grassland. As I said before, where you had permafrost or where you had glaciers and ice sheets elsewhere, the unglaciated places where the ground was still had plants was this grassland. They called it the Serengeti of the North. So the grasses were growing and the herbivores were grazing, the mammoths were grazing, and they probably helped. I don't know how much climate supported the grasses growing or the herbivores put the pressure for the grasses. I'm sure there was a relationship there. But that's right. Russia is 70% of the Arctic. What's going on in the world is really going to hurt science because we have to take a break in our yearly. My family is supposed to go to Chersky this summer, and we can't go now. And that's true for many of my colleagues who have projects and relationships with Russians, and we've worked together for decades, and all of that's coming to a halt. And if your goal is to study the Arctic, Russia is so important to it. And yeah, it has the largest stores of permafrost carbon.
I don't know people in Russia who are familiar with the Zimovs. It's as if all of the scientists that I know in the West who study the Arctic are familiar with their work, but the Russians have not. And I wrote a book about Russia, so I had a lot of contacts in Russia, not about the Arctic, but about political matters. And so, but my contacts in Russia are not, they've never heard of the Zimovs or their experimentation. So I don't find it easy to make contact with Russian scientists that I could interview about their work. And I kind of think they do not get the kind of support from the government that maybe you do, or that we would hope they would get.
Well, you should talk to Sergei and Nikita Zimov to get their answer, but I think part of that was initially on purpose. I'm very impressed with them as people and scientists. You have two men all by themselves in a remote corner of Siberia. They were far enough away from Moscow that they could do what they want. Mm-hmm. Tried to do what they do in Alaska or Canada or Scandinavia, there would be so much bureaucracy that would get in your way.
Oh, really?
But those men work very hard and they accomplish what takes hundreds of people in North America to do. So part of it was on purpose to be far away from Moscow, so that they could be independent in what they were doing. So if you remove yourself from Moscow and you remove yourself from the Russian Academies of Science system, I mean, they're still associated with Russian Academies of Science, but a lot of their work has been supported through international projects. There are plenty of Russians that know their work, though, and if you need some names of some Russian scientists, I could give them to you.
Okay, I want you to share your address book with me.
Sure.
I'd like to do this. I did talk to this guy who wrote the book Tree Line, and also there's a tribe in Manitoba of, I've forgotten what, Canadian indigenous people, but they have a herd of animals in a provincial park that they're tending, where they've combined a number of different, I think 5 different animals. You know, you've got elk, you've got caribou, you've got moose, you've got, I don't know what else, but a whole bunch of things that they don't normally live together as a single herd, but they've combined them as a single herd. And it seems to work. I've tried to interview them, but it's difficult. I mean, they are in a place where it's just technologically hard, for one thing.
Sure. Well, Meta, you would have a lot of fun talking with Nikita Zimov.
Wonderful. I will.
Yeah, my son has said, can't you mate some of these different species and have them all together? And I think he said the elk don't like the bison. So you could ask him, do they go as a single herd in Siberia, or what are those animal interactions?
Well, the guy who wrote the Tree Line book, I wish I could remember his name offhand, had pointed out something that was confirmed for me, I think last week, when I did an interview with a woman who's a naturalist. She lives in Toronto, but she studies caribou. And she says that, and they both say that what has is a risk to the people herding caribou, especially in Scandinavia, the Sami people, is that the rain, now it rains on top of the snow and it creates a layer of ice. Excuse me. And the caribou live throughout the winter by poking holes in the snow and getting at the frozen grass, but they can't they can't knock a hole in this ice, so they're starving. And that seems to be one of, if not the main, threat to their future existence, and of course to the livelihood of the Sami people who depend on herding them.
Yeah, I believe that it's not normal to rain in winter in the Arctic. And we had rain in December in Fairbanks, Alaska. There was 2 feet of snow, and then it rained, and then it snowed again. And we saw the impact on the animals. There were moose were not able to walk through the forest because they would punch through and it would cut their legs. If you imagine if you had to eat the vegetation beneath the snow, the moose eat the shrubs. But that meant that the moose only were going where people go. And then we also saw, I wondered, because we're seeing a lot of methane coming out in the winter. And so I wondered, does this ice layer in the snow prevent the methane from reaching the atmosphere? So I put my chambers down all over the snow, and I was seeing that the methane was still coming up through this icy layer in the snow and reaching the atmosphere. But if I punched through the ice, then I had really big gushes of methane coming out. So if we're getting rain in the winter, then it creates an ice layer in the snow that makes it challenging for animals, and it complicates the greenhouse gas emission story. I don't think it solves the problem, and methane will still get out. But it does seem like that icy rain, frozen rain layer can make the methane have to find its own different pathway to escape.
Would it be, you talk about making a funnel and capturing some local, plumes of methane. I've heard people who worry about trying to solve global warming globally talk about, is there some conceivable way that they could capture large areas, where there are emissions all over the Arctic Ocean in hundreds of miles area? Could they put a sheet over there of plastic, or, I've never heard of any sensible proposal, but is there any conceivable, realistic thing that you could imagine that could be done so that instead of having this methane escape into the air, we could capture it and use it? Because it certainly would be better than, even if we just set fire to it, it would be better to have it burn and turn into water. The residue would simply be water and CO2, which we don't like, but we like it a lot better than we like methane.
Yes.
What realistic technology do you imagine could be developed that would help in that way?
Well, you're asking a very good question. Some of these places where there's a tremendous amount of gas coming out of a focused location, we've calculated that an individual lake was enough methane to fuel 800 people, to provide the energy needs for a village in the Arctic of 800 people. So you don't have to ship diesel fuel in if you could just use the methane that's already coming out of the ground. The problem is those 800 people don't live next to the lake. So how do you get it to them? I've been working with a team out of the Berkeley area, the Bay Area, called Frost Methane, and they've been developing a skirt. It's a much bigger skirt than mine that you can drop down, and it burns the methane as it funnels the methane up, and then it burns it. So that's kind of a pilot project. And their idea is, could we deploy these with helicopters? So that's an idea. To me, the most practical.
Back up. What are you going to do with helicopters?
Well, they're trying to develop a skirt that could potentially be deployed at many remote locations. And the skirt, it's a big version of my bubble trap, my funnels. Mm-hmm. It's a bigger version of that. Mm-hmm. And it funnels the methane gas up, and then it burns at the top.
So you're going to have a helicopter come in and drop this thing over a lake.
Or maybe the people get out of the boat and they put it on the lake and then they move on to the next spot.
But they're going to leave it there, or are they going to come back and move it to the next lake?
No, you leave it there because the gas is coming out year round.
Okay.
So you there, and now it's doing exactly what you said. It is burning the methane that was naturally coming out of the ground, converting it to carbon dioxide and water vapor. Mm-hmm. So we have a pilot project going to explore that. But I think the most practical thing to do is actually to drill. And you don't normally hear people who want to stop climate change from saying, let's drill for more natural gas. But in this case, I think maybe there's wisdom in it, because if the methane is leaking out on its own and going into the atmosphere, if you drilled and put a well in and collect the gas before it got to the atmosphere, now you can pipe it to people who will use it without all the problems of condensation and transport once it comes up through the lake or the ground. So drilling in this case works in two good ways. One, you're preventing the methane from going to the atmosphere. People will get it and they will use it and convert it they'll burn it and use it, make electricity, heat hot water. The other good way that it's a double good thing is that those people that are using it in these remote Arctic villages don't have to ship diesel fuel in. They need energy anyway, and they're currently shipping very expensive diesel fuel in. Mm-hmm. Why not use the natural gas that's coming out and not bring the diesel fuel in and reduce the emission effect of natural leakage?
Well, that sounds brilliant. If it's
solution.
Concentrated enough to make it worthwhile. But if in fact it's just a little bit here and a little bit there and dispersed all over the Arctic or the permafrost areas, which is even much bigger than the Arctic, it doesn't seem realistic. But are there places where it is so concentrated that you could say this is the place to drill?
Yes. It's the places like these Siberian sinkholes or these lakes where we have mega seeps in Alaska. Those are leaking coal bed methane, petroleum sourced methane, sedimentary basin methane, and there's strong concentrations of it, and they are on their own leaking out to the atmosphere. So in those locations you could drill. But you're right, there are millions of other lakes each lake has thousands of smaller methane pockets. No, I don't see any practical solution for collecting the methane. Again, you could say, is there some way we could fertilize the lakes to stimulate microbes to eat the methane? Those things make me nervous, where we've doing these sort of experiments where we're really altering nature make me nervous, but might as well think about them. And
actually, no, you're onto something new for me, because I hadn't heard anybody say that. I have heard that there are bacteria that eat methane, but I got the impression that they're very fragile and not very cooperative. It's really hard to raise them, and you couldn't just drop in a capsule of these methane and expect it to populate a lake for you. And I don't even know whether I'm talking about the same kind of critters that you're talking about. Maybe they're algae or something that could do it. Tell me what these people have in mind.
I don't know what they have in mind. I don't remember if I've heard that idea or just thought about it myself, but you could look for natural ways. There are these microbes that consume methane. They are everywhere. So I don't know that you would need to inoculate lakes with microbes. I think those microbes exist, but maybe you can change the conditions in the lake that promote those microbes to be more effective.
Well, I read something about a woman scientist who's working in a lab trying to study these, what do they call them? Methanotropic or...
methanotrophic bacteria, methane oxidizing
and
bacteria.
Her difficulty is just keeping enough of them alive to study, because unless you keep feeding them the right amount of methane, they die. And it's apparently they're real touchy critters. So she has, I got the impression that just culturing them or keeping a population to study, not to mention the idea of putting them out in nature and hoping that they take over.
Well, I like I said, I think they're already in nature. It's a question of how do you promote the ones that are there? We are studying methane oxidation, and there's a ton of it that goes on. So it is there. I think in her case, it's probably a little bit like low bush cranberry plants. We like every September as a family to go out and pick cranberries, and we go to these hillsides that are covered in cranberries. If we wanted to try and transplant those cranberries in our yard, they won't grow. So nature does a very good job of some things. And this is where I think our human understanding falls short, and we just are not able to control nature as well as we would like to. And that's my biggest source of concern, is we feel the pressure to do so, but we're not God.
Oh boy. Well, I'm sure we're not God, but I'm sure glad that you're doing what you're doing, because this has been a wonderful conversation to me, really enlightening. And I really appreciate what you're doing, because it's so important and I think so interesting. So thanks so much.
You're welcome. Thank you, Meta.
Okay, bye.
Bye.
Katie Walter Anthony's book is called Chasing Lakes, and it's going to be available on May 17th, 2022, just a month from now. And you can get it through your own bookstore. You can get it through Amazon or Barnes & Noble or Books A Million or Bookshop or IndieBound or Target or Walmart. There are probably other places too, local bookstores that will get it for you. It's going to be $27.99 in US currency. And it's called Chasing Lakes, Love, Science, and the Secrets of the Arctic. And it sounds like a very personal and intimate conversation with or look at the life of this woman who I've found absolutely fascinating. So I hope everybody will get a copy of the book. I'm going to read it, and I'll see if we can get it reviewed in Peace Magazine, possibly in the next issue, which will be the July issue 2022. And you can always get Peace Magazine through Press Reader, which is go to Press Reader and look for Peace Magazine, and you can subscribe there. Now, let me tell you about our whole series. As you know, Project Save the World produces one of these shows 3 days a week, and sometimes more. This one happens to be episode 440. You can watch these or listen to them as audio podcasts on our website, tosavetheworld.ca. Eventually, we even post the transcripts there. When you get to the website, look around, because we have conversations going on there all the time about 6 global issues, plus potential reforms in governance, economics, and civil society. To find a particular talk show, enter its title or episode number in the search bar, or the name of one of the guest speakers. After you've watched or listened, scroll down and share your own thoughts about the show with the other viewers. This is a place for dialogue, so please join in. I'll see you there.